Guo Cheng Guang, 11 years old, grade 5, from YUMIN Primary School.
My name is Guo Chengxi, 8 years old, grade 2, also from YUMIN Primary School.
This lesson is Electromagnetic Dynamics. Chapter 1. Electric field and Gaussian law.
So now we're at Coulomb's law.
Coulomb's, right?
Yes.
So when it is in the vectors form, how many ways of writing do we have?
Three.
Yes, we have 3 ways. What is this?
Unit vector.
Yes, correct. This is the unit vector. And remember, when you have the r vector, the denominator becomes an r cube, right?
Yep. Let me ask you a question. So this is for 2-dimensional, okay?
Okay.
Okay. Let me ask that. Does equals to does it equals or not? That means
No.
you don't need to write a cross.
Okay.
So what should it be?
Well, don't forget about your x and the y.
Okay. So that means instead so it will be something so the coefficient I'll have the x and the y. Okay?
Yes. And a bracket.
Do you know what this equals to?
Your Q2. Wait, for that, what do you want to write?
Then what is this?
Well, for this, do you want to write it as xy?
Actually, what I want to write is like this.
Okay, so you want to write it like that.
So these two.
So basically, this part is our vector.
Yes.
Okay. Well, this is just for 2 dimensions, right?
What about 3 dimensions?
3 dimensions, you have an extra k.
So in 3 dimensions will be like this.
Yes, correct.
So since now we found all these, so why don't we know what is the unit vector when you add the modulus? It will actually be all a 1. You know that? Wait, Dad. Okay.
So this is also a 1, right?
Yeah.
So remember, for this is the unit vector. And for this unit vector, which is that r vector over r, right?
Yeah.
So actually, for this part, what can r vector be? Just take that this is actually 2D.
Okay, so it'll be wait. It's correct.
Remember, I didn't write it as a unit vector, okay?
Yes, it's correct. Like, if you add a unit vector, then back.
So remember for this, or, well, how to write it with the unit vector.
So,
yes, as we'll need to, this part will square. And that's how we actually find the length. So when we square, add them up. What is it? So it's actually half plus half. Exactly 1. So yes, this is actually the unit vector.
yep, let me ask you a question. What if it's 3D?
Okay, so 3D. So 3D, what would you like it first? Like for example, if it is just actually like
2, 3, 4.
okay, 1, 2, 3, 4. But do you know what these mean?
You don't need to do that, okay? It's okay. It's okay.
So actually for this, the 2, remember for this 2 is our x. The 3, what is it?
Y.
Y. Which direction is it? Which direction is the Y?
It will be like this.
This is the x. And the Y is here, right?
And over here, Z.
Yes, and over here is the Z.
Okay.
So right now for this, well, remember that it is actually with the over R. So what is a R actually? Do you know how to find it?
You only saying for the R or Y?
I just first find that R. So you actually have that Pythagoras theorem. So yes, correct. You got the right answer. Well, this is our R. What is this actually? This actually means the it is actually the length of this whole thing, right?
Okay.
So this whole length is actually just this square root 29, right?
Yes.
So what if we write it as, so we continue to write as in the unit vector?
Okay.
Remember, it's a 3. Okay, so for each of these, the 2, which is actually this x, right?
Yes.
So this x, x over the, this is actually the resultant, right?
Yes, also can call the hypo.
Yes, exactly. So actually from here, which is actually the adjacent over hypo, which is?
Cosine.
Yes, correct, cosine. So then for this, 3, which is the y.
Y and Z, which is the 4.
Okay, so for this,
the y is still a cosine as the y is also adjacent from this hypo, and the z is also adjacent from this hypo, so it's also a cosine.
Okay, yes. So actually all of these are cosines, right?
Yes, and what is it called? What cosine?
Okay, so you want to say the name of these cosine?
Yes.
It is actually something with the directions, which is that we actually have the directional cosine.
So, for example, like alpha, cosine beta, and cosine gamma.
Do you know what is the last 3 letters? Yes. So right now you can write this in the cosine. Write it. Remember, for the one with the x, we'll just name it as alpha, the angle. Then the one with y, we'll call it beta. And the one with z, we'll call that gamma. And don't forget about that k. So actually, how can we write this as? So actually no more equal signs.
Actually, you could have.
Okay, so you actually just wanted to write it in another way, which also actually can. So are you really sure that it's actually that way?
Yes.
So remember, this is actually just another way of writing that. But from here we can actually get a trigonal identity. I think you missed out the square. Okay? Well, this is actually easily confused with that sine square x plus cosine square x equals 1.
And we could change the cosine into sine, right?
Yes, exactly. Cosine square x changed into a 1 minus sine square x. Remember for the first is actually alpha. Remember, change it to a sine. Yes, exactly. That is actually a 2.
Yes.
So remember next time when you see these two, they are actually the exact same.
Okay.
Just that you convert them using a trigonal identity. Right?
Okay.
So remember for this time on the Coulomb's law. So actually we've learned all about these vectors, right?
Yep.
Well, actually here, the directional cosine, we can also have the maybe so-called directional sine, right?
Yeah.
So for all of these, are you clear so far?
Okay.
Do you have anything else to ask or say before we end all these?
If you like our videos, don't forget to subscribe to our channel.
Okay, so can we end our lesson over here?
Okay.
So we'll see you in the next lesson.
Okay.
Thank you for your watching.